Welcome to Algebra 1, Unit 7, Lesson 4.6, Part 1, Absolute Value Equations and Inequalities, Pearson Algebra 1, copyright 2009. I'm Mr. Pilarski, and our objective today is I will be able to solve equations that involve absolute value. It's good to remember when talking about solving equations with absolute value or talking about absolute value in general is that when you have the absolute value of a number, say like 4, it is equal to 4. But also, the absolute value of a number like -4 is also 4. So we have two different numbers that yield 4 as their absolute value, 4 and -4. So if we write it in terms of x, I'm turning things around here. The absolute value of x is equal to 4. There are two solutions. There are two numbers that when you substitute in for x, that will give you 4. X is equal to -4, or x is equal to +4. One of these two numbers will give you the solution here. And this is the simplest kind of equation you can solve. The absolute value of x is equal to 4. The solution is x is equal to -4 or x is equal to 4. So we're going to see how this plays out when it comes to solving more complicated equations with absolute value. Example 1t, solving an absolute value equation. Solve the following equations. In these particular problems, what we're going to have to do is solve for the absolute value. In example A, we have the absolute value of a minus 3 is equal to 5. So what we have to do is get the absolute value by itself. And what I mean by itself is we need to get rid of this minus 3 on the left of the equation, on the left of the equal sign. And to get rid of the 3, we add 3 to each side. Add 3 to each side, not 5. Not 3 and 5 anyway. The minus 3, the plus 3 on the left go away. Leave us with the absolute value of a is equal to 8. From what we just saw, by the definition of absolute value, our solutions in this case are going to be a is equal to -8 or a is equal to 8. So these are the actual solutions here. In example B, really not much different. Just adding, or just using decimals, and we're still going to use the addition property of equality. We're going to add 6.4 to each side. The minus 6.4 and the plus 6.4 go away on the left, leaving us with the absolute value of a is equal to, when we add on this side, gives us 8.12. So that yields a being equal to 8.12 or a being equal to -8.12. When you have absolute value equations, there's always going to be two answers. Not necessarily opposites as in this case. We're going to see that in example 2. But when you have absolute value equations, there's always going to be two answers. Example 2t, we're actually going to do two problems. Example 2t, we're going to do part A here, where we need to solve the following. The absolute value of 3c minus 6, close the absolute value, is equal to 9. In this case, since the absolute value is already solved for, but there are operations inside the absolute value, we have to use the definition of absolute value to rewrite this as two equations, a compound equation, using the word or. We've seen those in the previous lesson, in lesson 4 or 5, when we talked about compound inequalities. This will just be a compound equation. Now the first equation is going to be a duplicate of the first equation without the absolute values. So we'll have 3c minus 6 is equal to 9, or, because we can have one of two solutions, this is how we find the first solution. It's this equation without the absolute values, and the other equation is basically the same, except the right-hand side, you take the opposite of that number. And now we solve each equation. So to get this compound equation, we take this because we need two solutions. On the left of the OR is going to give us the one solution. On the right of the OR is going to give us the other solution. We write the equation on the left of the OR by copying this equation, the given equation, without the absolute values. And on the right-hand side, we find the other solution by the definition. It's the opposite of whatever this number is going to be. So it's 3c minus 6 is equal to the opposite of whatever that number is, in this case, 9. Now we use the properties of equality to solve each equation. You're going to notice that solving each equation is done in a similar manner. In fact, we're going to add 6 to both of these equations to solve. When we add 6 over here, they go away, leaving us to 3c. 9 plus 6 is 15, and we continue to solve the equation on the left by dividing each side by 3. On the left-hand side, the 3's go away. They divide out. They don't necessarily go away. They become 1 to leave us 1c, and 15 divided by 3 is 5. So our one solution is c is equal to 5. You should bring down your OR. And on the right-hand side, we're going to use the same basic steps. We're going to add 6 to each side. But because this is different than this, we get a different answer on the right. It's going to leave us with 3c on the left. On the right-hand side, we end up with negative 3. We'll divide each side by 3 still. And our second solution is c is equal to negative 1. So we have our two solutions here. C are equal to 5, c is equal to 5, or c is equal to a negative 1. Example 2t, part B, just a similar kind of example. In fact, if you're my student and you're watching this, I'm going to change this problem just a little bit. So if you can give this example to me on a piece of paper and give it to me in class. We'll call this a bonus assignment. We'll call it bonus assignment 4.6. Write that on your paper, put your name on it, copy this example down, you get some bonus points. We're changing the problem to 2 times the absolute value of 2 times c minus 12. Close the absolute value is equal to 10. To solve this problem, what we need to first do is divide each side by 2. To solve for the absolute value, as we saw in example 1t, we have to get the absolute value by itself. Even though there's stuff inside these absolute value, we need to get the absolute value by itself. We'll divide each side by 2 to give us the absolute value of 2c minus 12 is equal to 5. So now, to solve this, it's just like I did in part A. I'll have to write this as the compound equation, 2c minus 12 is equal to 5, or 2c minus 12 is equal to a negative 5. So now it's time to solve these equations. To solve these equations, we'll add 12 to each side. Adding 12 to each side on the left equation will give 2c is equal to 17. Dividing each side by 2. Twos on the left divide out, leaving us with c is equal to 17 halves, or that would be 8.5 as a decimal. 17 divided by 2 will give 8.5. And on the right-hand side, we'll solve in the same manner, adding 12 to each side. As we saw in the previous problem, that'll give a different answer on the right-hand side. That'll give 2c is equal to a positive 7. And dividing each side by 2. Twos on the left divide out, leaving 1c is equal to, that'd be 7 halves, or 3.5. Bring your OR down. So our solutions here, c is equal to 8, or c is equal to 3.5. Or I'm sorry, 8.5 or 3.5. When you're solving equations that involve absolute value, you need to have two answers. and separate those answers by or. This has been Mr. Pilarski. Thanks for watching. Bye-bye.